All right, so while we're thinking about graphs here, let's go back over domain and range. We talked about it a little bit last time, not a whole lot, but just kind of review domain and range. For a function, what are we talking about domain? It's the what? The x values. Usually we say it's the x values or input values. And the range is the other, right? The y values or the output values. Okay. And so we did, just the ones previous, I think, like if we had a function here, a table, said x was 1, y is 3, x is 2, y is 5, x is 3, y is 7, then here's your domain, right? 1, 2, 3. And here's your range, 3, 5, 7. All right, well, those are very, very restricted functions. On the functions we'll talk about, there'll be much more to the domain and range than just a few values. For example, if, let's just say I have an equation, a function. Y equals, let's just do a linear function. Y equals 3x, or f of x equals 3x, either one. On that particular one, the domain, again the x's, well, when you come to an equation like this, you're just thinking, well, what x's can x be to get real number values here? And in this case, what can x be? It could be anything, okay? We could say any real number or all real numbers. One way to say it. Now, if we, the ones we'll do here next, we'll be talking off of a graph. And so usually on that, different ways you can do it. But are you familiar with this terminology here? It means the same thing, doesn't it? It says this, you can go negative infinity to positive infinity, right? You can go backwards, forwards, as far out as you want to take it. Could be anything. Then what about the range? Well, that's a little trickier sometimes, but you just have to think. If I plug in any real number here, can y, what about y? What's y going to come out to be? Well, it depends on what the x is, but if x is a 2, then you got 6. If x is a 3, you got 9. If x is a negative 2, you got negative 6. So what about it? Can y be anything too? Yeah, y can be positives. It can be negatives. It's all real numbers too. All right. So it's also negative infinity, positive infinity. All right. Now, sometimes you will get restricted. We'll talk about this one more later on. But on like the square root of x, since we're talking real numbers here, can x be a negative number for a real number? If I plug in x to be negative 4, wouldn't I get something that's not a real number? It's an I, but that's not a real number. So doesn't x here have to be something greater than 0? 0 or greater? So we could say that this way. It could be 0. X could be 0. You run into problems when you get negative. So x has to be greater than or equal to 0. And then for the same reason, are we ever going to get, for the y values, are we ever going to get anything negative out of that? No. So y is going to, all right. So anyway, like I said, we'll talk more about these more later on, but I wanted to do that first. But the other angle we'll take on this as far as domain and range, from a graph. It'll be an important tool for us. So let's talk about the domain and range from graphs. All right, well, let's take a look at this one. Number one. Okay, so the question is, what is the domain? Just use abbreviations there. What is D, what is R? What is the domain, and what is the range? Based on this function, all we have is a graph. Maybe we could come up with a function, but what about these, domain and range? Well, again, it gets back to the definition of domain. Domain is the x's, the x values that here we possibly have. Well, the x-axis being this one, we're looking at this axis here, aren't we? And what do you see as far as x values go? If I put points to this graph here, what x's would I have used? Could possibly. I could use a -2. X is -2, don't I? -1, I have a point that has an x value of -1. Don't I have a point that has an x value of 0? 1, 2, 3, 4. All these x values go with a point up here, so those are part of the domain. What is not a part of the domain here? Anything below -2. That's right. So doesn't x have to be something greater than or equal to -2? You with me on that? Because I don't have any x values, -3, -4, -5. Okay? So x has to be greater than or equal to -2. Now, the other way, the book probably prefers that you use this interval notation, like this is -infinity, +infinity. The interval notation for this one is, well, you start at -2, and then you go out to infinity, don't you? And you include -2, so you bracket it off. And infinity, you always use the parentheses on it. But is that okay? -2 to infinity. Now, the range, the y values. Looking at the y values. Is it the same? It was the same on both of these, but that won't always happen. The range here is something a little bit different. What y values are used here? What all right, well, let's think about it. Now again, this is kind of the starting point, so it doesn't drop any below that. So it starts here and goes out here, okay? All right, so do I see a y value of 1? Would there be a point with a y value of 1? Yeah, sure would. There's a y value of 1 right there. Is there a y value of 2? Yeah, that point would have a y value of 2. 3, yeah. Whoops, that's 3. There's 4, that's 5, sorry. Okay, 3, yes. 4, yes. 5. Yeah, there's a point that has a y value of 5 in it. So all those, 1, 2, 3, 0, yes. What about the negatives, though? Anything, is there a y value of -1 anywhere on this graph? No. No, there's not a point, because it just stops right there. There's not a point that drops to this y value of -1. There's not a point that drops down to -2. So nothing below what? The y values basically start where? Start at 0, don't they? So the y values are from 0 on up. And there, what about a 10? Is there a y value of 10? Yeah, it's going to take a while, but that one's angled up, and it'll continue that path, and so it's angled ever so slightly, but it does eventually get to 10. So anything from 0 on up. So y values start at 0, equal to 0, or greater than 0. Or how could we say that? What would the interval notation be? 0 to infinity. Is that okay with me? All right, okay. All right, here's another one. Number 2, domain and range of this one. It's kind of a half circle, semicircle, so it goes from here to here, up to there. All right, so like I said, a semicircle. Start, stops right there. Nothing further. Domain and range of that particular graph. All right, well, the domains being the x values. Which x values do I use here? Well, looking at the x values, I've got a -2, obviously. It's utilized. And then -1, yeah, I've got a point up here that has an x value of -1. At 0, yeah, there's a point that has an x value of 0, 1, and everything in between. Yeah, there's a point with an x value of those also. So what are you thinking? -2 to 2, and that one probably is easier to use the interval notation. -2 to 2 meaning everything from -2 to 2. Now, if you write that as inequalities, you know how to do that one? This looks like this. If you wanted to use that. Okay? What about the y's? Basically the same story. There's only a certain range of values for the y values also. Where do the y values go from? You tell me. 0 to 2? Yeah, I've got a y value of 0. Actually, there's two places that have a y value of 0. That's okay. Because this is a function, vertical line test. Thank you. But yeah, 0, y value 0 goes over here, y value 1 goes either place. Would have that, 2. But once you get past 2, 3, 4, and beyond, there's nothing y value points with the y value of that. And below 0 is, there's not a y value below that. 0 to 2. Or, if you want to write it this way, 0 is less than equal to y is less than or equal to 2. Is that okay? All right. One other of those, number 3. Little tricky one here. Got a -1 x-intercept and a 3 x-intercept, and then it's got a high point here, 1, 4. Okay. There it is. That's my function. What's the domain? What is the range? We had something like that earlier, but it's kind of turned over. But let's see. The domain, the x values. All right, well, again, this I drew the arrows on it, but it goes on off. So this graph continues on out that way, on down that way. So those two just keep going out as they're going. So what about the x values here? What x values are used, so to speak? It'd be all of them, wouldn't it? All the x values here are used some way or another. we know negative 1 and 3 are. You've got definite points there. You got 1 and 2. You got definite points, x values there. But what about, what about out here, negative 10, positive 10? Well, this graph is angled out, and so there is going to be a part of the graph eventually, way down here, that's associated with this x value of negative 10. Same thing for positive 10. Same thing for positive 100, negative 100. Any x value has a point associated with it. So that's all real numbers, okay? Or negative infinity, positive infinity. Okay? What about the range, though? The y values. Do we use all the y values? No. Looks like it doesn't go anything beyond the y value here of 4. So 4 is the biggest, and then it's, how would you say that? Okay. Now, since you mentioned that one here first, this was a little tricky. 4 to negative infinity. Actually, doesn't it go the other way? Negative infinity to 4? Because you start with this would be the smaller number, this would be the bigger number. So, yeah, that's why I wanted to mention that one. If you do that, it's negative infinity to 4, not 4 to negative infinity. I know what you mean, but technically it should be the other way around. Or how could we say that with an inequality? Y less than or equal to 4? Either one.
Would it be bracketed?
Yes, bracket. Thank you. Yes, should have a bracket on the 4. Thank you. Because you want to include the 4. Okay? All right. So anyway, that, like I said, that'll be a nice way of doing the domain and range when we come across a function and we get the graph going. All right. Any further thoughts or questions on these domains and ranges? All right. Another definition, I guess, if you will, that we come across from time to time are the zeros of a function. What we mean by the zeros of a function. Well, here's the definition. The zeros of a function are input values x values for which the output value is 0. Input values for which the output value is 0. Or, in normal notational terms, it's the x values for which f of x is 0. Right? The x values are the input values, and so the f of x are the output values. So this is what it means. Zeros of a function are the x values when the f of x equals 0, where the f of x equals 0. Okay? For example, f of x equals 2x plus 8. The zero of this function is x equals negative 4, or just negative 4. Do you see why? Because if I plug in negative 4, what's the output value? Well, if I plug in f of negative 4 to the input of negative 4, I get 2 times negative 4 plus 8, which gives me 0, doesn't it? Negative 8 plus 8 is 0. That's what we're saying. The zeros are going to be those x values that make the function value come out to be 0. Okay? All right, now, how do we find then? I gave you that one to start out with. How do we find the zeros of a function? Well, to find the zeros of a function, you should choose the definition here. To find the zeros of a function, set f of x to 0 and solve for x. Okay, that's how you find them. Because that's what you want, right? You want the f of x to be 0. We could have done that with this one. Set the f of x to 0 and then solve that out, and you get x is -4. But, yeah, that's how you find zeros of a function. Set the f of x to be 0 and then find your x. Okay? All right, so let's find a couple of zeros here. Number 1, find the zeros of 4x minus 10. F of x equals 4x minus 10. Find the zeros there. 0 or zeros. Sometimes there's 1 0, maybe 2 zeros, maybe 3. Could be a lot of zeros, but see how many we get here. All right. So when it says zeros or zeros of a function, that means what is 0? F of x is 0. So you just set f of x to be 0. So I get 0 equals 4x minus 10. That just sets up an equation to solve. How we solve that one? Add the 10, divide by 4. And reduce, that one reduces to 5 halves. Okay? So the 0 of this function here is 5 halves. 2.5. All right, now, what about the plugging in x to be 0? Would that give me a 0? Not necessarily. Because if I set x to 0, do I get the f of x to be 0? No. If you plug in x to be 0, in this particular case, we get -10. And that is not a 0, is it? -10, f of x is -10. That's not a 0. Now, sometimes when you plug in 0, you get 0, and that would be a different case. But, yeah. When you're finding the zeros, it's f of x equals 0, not the x is 0. Okay? All right. So here's another one. Let's say we've got f of x equals 3x squared plus x minus 10. Find the zeros there. Well, as we know, when it says find the 0, what does it mean to be 0? It means f of x equals 0. So set f of x to be 0. And solve accordingly. How do I solve that one? Well, a little factoring or quadratic formula. Think of factors. 3x and x for 3x squared. Minus 10 with plus x in the middle. I think it's going to be a 5 and a 2. Plus 2 and minus 5. Isn't that going to be it? That'll be 6x. That'll be minus 5x. Yeah. And those total to be plus 1x. Just what I got. Okay? With me on that? All right. So then you set individually those up equal to 0. 3x minus 5 equals 0. X plus 2 equals 0. Add the 5, divide by 3. 5/3. Subtract 2. These are my zeros. negative 2 and 5/3. Is that okay? Move that over. Okay. Got off the screen. All right. One more. For this, g of t, find the zeros. G of t equals the square root of 5t plus 7. Couple of reasons to mention this one. This one's not an f of x, it's a g of t. So what do I set equal to 0 for the zeros of this one? G of t equals 0. All right. Yeah, it's the function value, the output value that's 0. In this case, it's g of t. So I set g of t equal to 0. And then solve that. How do I solve that? Square both sides. Zero squared is 0. Square root of 5t plus 7 squared. What is that? We did these earlier. Square roots cancel. So you get 5t plus 7. Subtract 7. Divide by 5. Negative 7/5 is t. And so negative 7/5, that's my 0. This one just has 1 0. That one, previous one had 2 zeros. Like I said, it could be 1 0. It could be 2 zeros, 3 zeros. Just depends on the type of function. With me on that, okay?